My name is Henning Löser. I am responsible for the Audi P Lab or Production Lab, a department of technology development and production. And I keep on saying we are the nerds, the morons that test the rough crap. And we have the task to make those break into cold sweat that have to deal with it in practice, awaiting what next. What do I want to do today? I would like to give you a brief view into the Audi group, facts and figures, and I want to talk about a product that we initiated that has left infancy stage, but later more on that. So let's talk about Audi Group. As you might know, Audi was established in Zwickau in 1909, more than 100 years ago. It has changed the names, grown, and for some years we have been part of the Volkswagen Group. Those 12 brands are part of the Volkswagen Group. There is a premium brand group, as we call that. Part of that is not only Audi, but Lamborghini, Bugatti, and Bentley. And we combined all that in order to be able to combine matters and act synergistically. Now, what are the figures within the Volkswagen Group of Audi Group? In sum, almost 1.7 million, 8 million vehicles delivered. Where did we produce them? Well, those are the companies, the factories throughout the world where we produce vehicles from the premium group, either completely or final assembly. Thus far to the Audi Group. And now let's broach the question, what are those guys doing? What is Edge Cloud for production? I would like to ask you, or me, why are we doing that? It's great. Up and running. Why change a running system? We have been automating manufacturing for decades. Great thing, but nevertheless, especially in manufacturing, it's always about improvement. Getting the next bit out of it. And I like to compare it to competitive sports. Faster, higher, better, more efficient, higher quality, better standard. And that's what we have. This is a motto from our P strategy, pushing the limits of innovative and sustainable production. That's where we're heading. We want to shift the borders, shift the limits in order to provide excellent production and provide excellent vehicles to our customers. For quite some years, almost 10 years, we started in 2014, I made contact with it, and we've been talking industrial Internet of Things, Industry 4.0. And what we started, it started decades before that with Zinn, is the topic to use more sensors, more computing power in order to streamline and optimize our production. And we made giant strides ahead. For example, now we have a rupture detection in the press works. We can automate, or we can detect the ruptures automatically. Within the Volkswagen Group, we developed an AI that tells us, based on data, is this welding point of good quality or not? This means that all of a sudden our quality processes can be run completely differently now, and at the same time it means something else. It means that we now have sensors, algorithms, which are interfering or at least influencing core processes, and where we find, hey, that's cool, that helps us. There is a business case for that. We want to realize that, implement that, and we more and more add computer technology to our manufacturing, more controllers, image detection, cameras, some things that tell us about surface, read-in, a label, and so on and so forth. We are living in a time where a couple of years ago you would have said that's science fiction. Now we can realize that the question is cast. But a lot of what is conceivable is doable technologically. And then, is it economically viable? There is a difference, and we only want to do the economically viable things and reasonable things. And the examples I've just given you are examples based on which we saw, unless we change things fundamentally, we will encounter problems before long. Let's take the AI algorithm example. Is a resistance welding point good or not? With that information, you can tell quality assurance, you don't have to look at this module, that's okay, but with this module number, look at welding point 7, I'm not quite sure. Do sonography. If ultrasound detection says it's okay, then you feed back the data to the algorithm. It keeps on learning, and the next time the AI algorithm will know it's okay. With another point, there is insecurity as to the quality. Then you measure and find fault, and that will also train the algorithm. That is the essence of training algorithms that keep on evolving, which brings us to the problem. Okay, now, if only twice a week this algorithm is sent to all the welding modules, how can we do that? We cannot go to every welding module and upload the new algorithm. There must be other options here. Just imagine camera technology. You have a new camera, you train an algorithm that detects ruptures better and better, and sometimes the algorithm isn't sure and says, well, I'm not sure, and you train the algorithm, and then you have a new algorithm. You have to roll it out and spread it, and of course you don't want to walk around doing that. That was the setting behind where we started, and we ask ourselves, knowing that also in future there will be more and more applications we want to use, that we have to use, while at the same time we have to make sure that we manage software and hardware updating efforts. Let me give you some figures here. Today, roughly, only in our two German plants, we have 15,000 industrial computers up and running that are critical to production. 15,000. We have, I don't know, a couple of thousands of PLCs on top in our plants that are essential for process control. Open loop and closed loop control, and all these devices, IEC 62443 was mentioned. Of course, it needs to be up to date. And now, let me stretch your imagination a bit. The options of Internet of Things are gigantic. I don't know who deals with Zigbee to automate the lighting at home. Wonderful. You sit in the living room with your glass of wine, you watch your favorite movie, the backlight of the TV is synced with the contents on the screen. If you leave the room, the light is switched off, and your daughter doesn't leave the light on all night. So energy saving, which is all the rage at the moment, you can do all that. And it is a huge gain of convenience to use these smart home devices. Perfect. And then, what is my energy consumption? How high is it? So you make sure that this lamp also communicates to you how much energy is consumed. You have an overview. You notice that I turn on the washing machine when the sun is not shining and my photovoltaic plant is not yielding any electricity. Let me change that. You optimize your energy consumption at home. Perfect. And then just imagine, because you have these logs about your bulbs and lamps, and for some reason the log is log4j. There's a safety gap, and there in every single bulb a safety patch needs to be installed. At home you think, is it a problem? Then you think, Zigbee, that is wireless, maybe you can hack it. Then it costs 1 weekend, if you're lucky, maybe 2 weekends if you're less lucky, and then you have updated your lamps because you have one manufacturer. The manufacturer was kind enough to provide you with a tool for it to work smoothly. You've downloaded the tool behind your firewall. You install everything. After 2 weeks, this is done and dusted. The safety problem or security problem is spanned. And now, think of it at a plant scale. You don't have 1 or 60 light bulbs. You have 100,000 light bulbs. And these 100,000 light bulbs come from 1,000 different manufacturers. The same problem. Of course, in your company, you want to do energy monitoring, you activated logging, you need to update each and every of these 100,000 light bulbs. And there, the 1,000 manufacturers say, of course, I've understood it. I have this service that you have to install. Then you bore a hole into your firewalls all the way to the light bulb, and then the update will be installed. And you do that 1,000 times because you have light bulbs from 1,000 manufacturers and your firewall consists of holes only. But going there and update each light bulb on the premise doesn't make sense. You will never finish. And this triggered us to say, hey, now wait a minute. How does Industry 4.0 work? We want to have these intelligent agents who decentrally make decisions, control locally to optimize our processes. And if we have these decentralized agents, how do I maintain that stuff? And we can't. I mean, we are a car manufacturer. We don't want to develop these agents ourselves. We can't. We don't want to. We want a solution. How we can integrate it into our systems such that we are on the safe side security-wise, that our maintenance colleagues have tools so that they know and understand what is happening, what do I need to do, how do I roll out updates, how do I install updates. I need watchdogs to see whether things are okay or running out of kilter. And this was the idea, and there 4 years ago, a bit more than 4 years ago, The problem was 15,000 industrial PCs. Let's do an OS update from Windows 7 to Windows 10. How do you do that with 15,000 PCs if this update needs to be done in the 20-minute shift break? Well, that's where we started asking ourselves, isn't anywhere out there, outside of automation and industry, aren't there any solutions that take the problem away from us? And there we found that in computing centers, this problem is solved completely differently. In computing centers, we are talking about hyper-converged infrastructure, a word that I needed to learn long and hard. And what is it all about? It is about separating software and applications from the hardware they run on. I introduce a virtualization layer separating hardware from what runs on it. And when I do that, I get numerous benefits. First, all my applications can always be run on 100% the same hardware because it's a virtualized environment. It clones itself. It's the same hardware again and again. So problems that did happen on our PCs after only 60 days, the PC will crash. It only was up and running for 60 days. Why would it crash? And then you find, okay, in this PC, the graphics card was damaged. We installed a new one that requires a different driver. The driver wasn't tested adequately, had a memory error, and the RAM overflowed after 60 days, and the PC crashed. The solution is easy. Boot up, and it works. But it's so complicated to find the mistake. Why? Because that is a symptom saying that crap doesn't work anymore. Now, knowing what it was, so a posthumous analysis is hard to do, and you don't have the time. All there is to it is it needs to be up and running. So turn off, turn on, and it will spring back to life. Now, what about if it takes 60 days? Let's reboot all our PCs after 30 days. Problem solved. If you move to a virtualization environment, your options change. In computing centers today, you can check what application requires what memory. And if memory is depleted by an application, you can react up front and see why is that. You restart the same application, you swap from one to the newly powered up application, can freeze the old one and can analyze the problem. Is it really the problem of a software with a memory problem, or has anything else happened? Is malware going on in your memory? You can control that. The watchdogs, the automation scripts exist for the computing centers with 15,000 dedicated industrial PCs. You do not stand a chance. That's where we started from, and then we looked at our production. Here, a picture from the setup of our modular assembly. On the left-hand side, you see a typical interval. You see 4 industrial PCs here. 2 have the task to run a monitor for the employee to see what he has to do next. Then you have 2 PCs with that operate scanners, crew fixers, that produce quality relevant data, program a torque and check the torque, which is then fed back. But in one production cycle, 4 or 5 PCs is anything but unusual. That's what we need today. And the same goes for our switchboards for automation. This is a switchboard or switch cabinet just so that a PLC can run there. And our motivation was, which of all these applications that we have here, which of these applications can be integrated in a hyper-converged infrastructure? We have various plans. The first is a torque software. The next is our manufacturing execution system. The third is our quality control system, with which we check whether the right data containers were loaded into the vehicles. Is everything working? And the most important discipline, PLCs or programmable logic controllers that we have for automation of the things that we build in ourselves. That is what we want to bring in the world. That was our vision. And of course, we started grand because things will whittle away by themselves. And the last thing is really a technical challenge where quite some issues have to be solved. If you don't have a PLC in your automation cell, what do you do with a field bus? Field bus is a layer 2 protocol, and all of a sudden you take the PLC away and transplant it somewhere else, and between the 2 points you open a layer 3 network. Why layer 3? Because you want to do micro-segmenting, you want to make sure that various devices or certain devices only communicate with those endpoints that they're supposed to communicate without communicating with all and sundry. And if you do all that, you face the problem, I have a field bus protocol, and I need to feed it through the network into my computing cluster in there. The application of PLC is running, the signals need to be fed back, and all that in the latency times we need to control our plants. Safety, 8 milliseconds round-trip time for signals, that's what we demand. 8 milliseconds is the time you have to feed the data from a robot to a PLC and back. As of today, if you have a hardware programmable logic controller, the network is not the problem. That's always fast enough. But if you add a switch, a layer 3 switch, not only one, but maybe you need 4 or 5 till you are where you're heading. What time is used for that? So in 2019, we started dealing with the network technology with Cisco, asking ourselves, how can we put that up? Is that pie in the sky thought about by the nerds in P-Lab? And the answer was, well, it's not that banal and easy, but in the meantime, we have come so far that we assume that it works. First, latency-wise, and you have to make sure one thing, you have to make sure that this network is highly available. Why? If the signal isn't fed back within three times within the interval time, the machines stop. So, just disturb or disrupt the network to stop production. But that's not what we want. But you have to think about how can I guarantee high availability, that it is as stable as what we know today, where we directly wire things, while getting the benefits that we get from a layer 3 network with micro-segmenting. Well, then we found out yet another thing. Everyone is talking about cloud, and if I think of cloud, cool. I don't have any PCs, they are in Frankfurt. Someone else can take care of them. That is ingenious. And the answer is, careful, 8 milliseconds latency. I learned at some stage 3 times 10 to the 8th meters per second speed of light, so that's about 300 kilometers per milliseconds such a signal can travel. 300 kilometers Ingolstadt, Frankfurt, depending on the wires. That's tight. Then you have 2 milliseconds just for traveling through the cables, and it eats away from your 8 seconds, and every leap through a deep inspection firewall costs you another 1 or 2 milliseconds, and if you are outside the production domain or network, then you will run into problems. So we need to build that up in our plants on premises in order to guarantee the latencies. And then the next question is, and that's where we also work together with the colleagues from CODESYS, what does that mean for safety and PLC in a hyper-convergent environment? How does that work? How do I certify that? The field bus that we have is ProfiNet. How do I tunnel ProfiNet there? How can I certify it in a ProfiNet conformous way? What does the TÜV agency say? We've been doing that for years, making advances, making headway, because we want our factory of tomorrow to look like that. The entire hardware that we install at the shop floor no longer should be at the shop floor. We want to change the philosophical view. I need functionality as automation technology. There I get a box providing functionality. And we want to change it to, I want functionality. Functionality is a piece of software, and I dissect it from the hardware. And once we've done that, we are certain that our idea of the 360 factory can be much more efficient. Well, that was, as I said, an idea from the Audi production lab, the nerds. And this year we started to say, okay, this will work. This is not just a pipe dream concocted by some nerds in a lab, but we want to realize it, implement it. This year we established a new department, Edge Cloud for Production, and the task of that is to make this series appropriate. We started this year in Neckarsulm, where at the Büllinger Höfe we will convert the systems, not with PLC, but in assembly, what you saw. After one step after the other, then also fastening control. The testing software is already virtualized. It started in November, so we can show in a small factory like the Überlinger Höfe that it is manageable. And in a next step, this concept is to be rolled out worldwide for new vehicle concepts, not only with Audi AG and the premium brand group, but it is our goal to have this concept throughout the Volkswagen Group. Which brings me to the end of my presentation. The red light is on. Thank you very much for your kind attention. And if you want to, I will be glad to answer your questions. Thank you so much.